The second type of salts are hydrolysis of, okay students, listen carefully, hydrolysis of strong acid, okay, strong acid and weak base salts. So for example, strong acid and weak base salts are ammonium chloride, ammonium nitrate, zinc sulfate, and magnesium chloride. These type of salts are strong acid and weak base salts. For example, ammonium chloride you have to take. This ammonium chloride is formed from ammonia, NH3 and HCl. They are combined in water, they are combined to produce NH4Cl salt, in which this NH3 is a weak base, okay students, and HCl is a strong acid. Okay, now it will be ionized to gives NH4 plus Cl minus ions. Now this NH3 is a weak base. Its corresponding conjugate acid is NH4 plus. This is strong conjugate acid. Weak base formed conjugate acid is strong. So whenever this kind of salts, strong acid and weak base salts, these salts are dissolving in water and forms cation and anion. Means for example, in water, in aqueous solution, it forms NH4 plus and Cl minus. This NH4 plus means cation. This cation is a strong acid. Cation is a strong acid. It reacts with water and produces H plus ions. That's why the resultant solution has acidic in nature. So this type of salts, weak base formed corresponding conjugate acid. Means cation, NH4 plus, like cation is strong. So this cation reacts with water. This cation of the salts reacts with water to forms H plus ions. So commonly I used the cation symbol is M plus. This cation reacts with water and produce H plus ions. So the resultant salt means strong acid, weak base salt dissolve in water and finally producing H plus ions. So excess of H plus ions are present means the resultant solution has acidic in nature. Now, and it exists equilibrium state. So that equilibrium constant is called as hydrolysis constant, I said. So for the above reaction, hydrolysis constant. So for this above reaction, hydrolysis constant is also known as equilibrium constant, is equal to the concentration of products of concentration of product, means MOH into H plus by M plus. Here water concentration we don't consider because only salt only we have to consider. In the above equation, just what I am doing, just to getting Kw, just I multiplied and divided with OH ions concentration. OH ions concentration I multiplied, then that value is not changing. Now this H plus ions concentration into OH minus ions concentration is nothing but Kw. We know very well, ionic product of water. Next, Kb is equals to, for weak bases, ionization constant or base dissociation constant is equals to, formula already we know that. What is the formula, dear students? That is M plus into OH minus by MOH. Like base I am considered as MOH is a base. Now it is reverse is there. So the reverse is, that's why MOH by M plus into OH minus is nothing but 1 by Kb. So the KH formula, hydrolysis constant formula for strong acids and weak base is equals to Kw by Kb. Kw by Kb. You have to remember that formulas are very, very important. Okay, students. And degree of hydrolysis. This degree of hydrolysis definition already I said. Degree of hydrolysis means number of moles of salts ionized by number of moles of salt taken. So that formula is equals to root over Kh by C. Root over Kh by C. Where is C is equals to concentration of salt. C is equals to concentration of salt. Okay, now this kind of salts dissolve in water, means strong acid and weak base salts dissolve in water, and the resultant solution has acidic nature, I said. So the resultant solution, why it is acidic nature, dear students? Because it produces H plus ions, it undergoes cationic hydrolysis. It undergoes a cationic hydrolysis, means strong acid, weak base salts undergoes cationic hydrolysis and produce H plus ions. Hence, it has acidic nature. It has a acidic nature. If acidic nature is present for the salt, means salt solution means its pH value is less than 7. The pH value is less than 7. That's why pH of this kind of salts means strong acid plus weak base salts. Weak base salts pH formula is equals to, pH is less than 7. That's why, because KH is equals to KW by KB. So that KB is denominator is present. You have to remember, that's why 7 minus half PKB of PKB. KB value they will give. Then how to calculate PKB, dear students? Minus log KB. Sorry, PKB formula is equals to minus log KB. Okay, like pH is equals to minus log H plus ions concentration. The same way, PKB is equals to minus log KB. So that KB value they given means we can convert, we can calculate PKB value very easy. That value you have to subtract here. Means 7 minus half PKB minus 1 by 2 log C. C means concentration of a salt. Concentration of a salt. These are the main important formulas for strong acid, weak base salts. In examination, explain the strong acid, weak base salt hydrolysis like they will ask. So just you have to write these pH formulas and all, no need to write. Just you have to write what kind of hydrolysis it will take place, and you have to write equilibrium constant or hydrolysis constant. KH formula just you have to write is enough, and degree of hydrolysis H formula also we need to write, it's enough. Okay, next third kind of salts. Listen carefully, the students. Third one, the third one is reverse, means weak acid, strong base salts. So we are taking weak acid, strong base salts. So weak acid, the acid is weak and base is strong. Like the salts are, for example, acetic acid, CH3COOH. Acetic acid is a weak acid. It combined with a strong base like sodium hydroxide, NaOH, and produce CH3COONA, sodium acetate. So this kind of salts undergoes what kind of hydrolysis? What kind of hydrolysis? So this in water it produces CH3COO minus and Na plus. Okay, among this positive and negative ion, which is strong? Because CH3COOH is a weak acid. It forms corresponding conjugate base. CH3COO minus is a conjugate base. Conjugate base is strong. Already we discussed in Bronsted-Lowry acid base theory. Weak acid forms corresponding conjugate base is stronger. So this anion is strong base. So this kind of salts, weak acid, strong base salts, example sodium acetate, potassium cyanide, sodium carbonate, this kind of salts mainly undergoes anion hydrolysis. Anion hydrolysis means anion of that salt, anion of the salt reaction with water and produce OH minus ions. Means the resultant solution having more OH minus ions means the salt solution has basic nature. This salt solution has basic nature. If basic nature means what it is, dear students, we know that. So bases pH value is more than 7. pH value is more than 7. So for this kind of salts means it undergoes anionic hydrolysis. So here acetate ion place anion A minus I am taking. This anion hydrolysis general equation. So for this anion hydrolysis we have to derive hydrolysis constant. We have to derive a hydrolysis constant. Hydrolysis constant KH is equals to, if you are writing that in the above reversible reaction, the hydrolysis constant is equals to concentration of acid into concentration of OH minus ions by concentration of anion. So in the above numerator and denominator both are multiplied with H plus ions, then it becomes the KH is equals to Kw by Ka. Ka means acid dissociation constant. Now degree of hydrolysis is equals to root over Kh by C, where C is equals to concentration of weak acid and strong base salt. Weak acid and strong base salts. Okay, students. Now for this kind of salts, pH value is more than 7, I said. So pH value is more than 7 means the pH formula, how to calculate when weak acid, strong base salts are dissolving in water, its pH value, how to calculate, dear students? The pH formula is equals to 7 plus half, denominator Ka is there, half 1 by 2 pKa plus 1 by 2 log C. This is the formula. These formulas are very, very important for JEE and NEET examination. Okay, students. And for board examination also, by using this formula, we can calculate the pH of weak acid, strong base salts in the given solution. Okay. Yes. Next, third kind of salt hydrolysis. Sorry, fourth kind of salt hydrolysis is hydrolysis of weak acid and weak base. Hydrolysis of weak acid and weak base. So both are weak nature only, weak acids and weak base salts. So weak acid and weak base salts. So like ammonium acetate. This ammonium acetate is formed from acetic acid CH3COH plus NH4OH, ammonium hydroxide. Both are weak and produce CH3COO NH4, means acetate ion and NH4 plus, and water it will produce. Now this type of salts in water and produced cations and anions CH3COO minus and NH4 plus. This CH3COO minus is a conjugate acid, is a strong weak acid produce conjugate base. Weak acid produce conjugate base is strong conjugate base, and it is also strong and weak base produced conjugate acid is strong conjugate acid. So both cation and anions are strong conjugate acids and conjugate bases. In this type of salts produced, both cations and anions are strong nature, so they can react, both can react, means cation will react and anion will react, means this undergoes third type of salt hydrolysis, means positive and negative ions both reaction with water, means it undergoes both cation and anion hydrolysis. So water will be ionized to give H plus and OH minus ions. So this H plus ions goes to an negative ion and OH minus ions goes to positive ion, means MOH and HA, means it is a base, it is acid will form again. Okay, means that's why these weak acids and weak bases cannot ionize. Ionization is very, very less for these cases and exist equilibrium state, and that hydrolysis constant or equilibrium constant is equals to, finally in the above reaction hydrolysis constant or equilibrium constant if you are written properly, then we'll get Kw by Ka into Kb, means we have to multiply it with both H plus ions concentration into OH, denominator and numerators I multiplied with Kw, means H plus ions into OH minus ions, and by H plus ions into OH minus, then it becomes Kw whole by Ka into Kb will comes, and degree of hydrolysis formula is equals to root over Kh. Now this kind of salts in aqueous solutions has what kind of nature? They have either acidic nature or basic nature. So it is depends on their acid dissociation constants as well as base dissociation constants. Okay, and pH is also depends on K and Kb values. Yes. this type of salt solutions, nature is depends on, means the resultant solution nature is depends on Ka and Kb values. If Ka value is more, sorry, if Ka value is equal to Kb, then the resultant solution has neutral in nature. If neutral means the pH is equals to 7, pH is equals to 7, because both are equal. Pk and Pkb equal means it's a negative sign, it becomes 0, then pH is equals to 7. If Ka value is more then Kb, then the resultant solution has acidic nature. Ka means acid dissociation constant, it is more when compared with Kb. Kb is less, then the resultant solution has acidic nature. So in that case, otherwise if Kb is more than Ka, in that case the resultant solution has basic nature. So in these two conditions, its pH value is equals to, its pH value is equals to, or pH formula is equals to 7 plus 1 by 2 pKa minus 1 by 2 pKb, 1 by 2 pKb. So you have to remember this formula, important. Okay students, these are the different types of salt hydrolysis. So there are 4 types of salts are present. For board exams also is very, very important. 4 types of salts are present. One is strong acid and strong base salts. The second one is strong acid and weak base salts. The third one is weak acid and strong base salts. And fourth one is weak acid and weak base salts. So the first one, no hydrolysis. No hydrolysis. This strong acid, it undergoes cationic hydrolysis. Cationic hydrolysis, and the resultant solution has acidic nature. And this undergoes anionic hydrolysis. Anionic hydrolysis. This undergoes both cation and anion hydrolysis. And nature of the solution is depends on both Ka and Kb. If Ka strength is more than Kb, then the resultant salt has salt solution has acidic nature. Or if Kb value is more than Ka, then the resultant salt solution has a basic in nature. In that case, pH value is equals to 7 plus 1 by 2 pKa minus 1 by 2 pKb, 1 by 2 pKb. Okay students, these are the different types of salts hydrolysis process. Okay, what is salt hydrolysis definition important, and in examination they will ask explain the hydrolysis of strong acid weak base salts, explain the hydrolysis of weak acid strong base salts. Like that way they will ask the questions, and pH formulas and degree of hydrolysis and hydrolysis constant formulas are very, very important for objective examination. Okay students, next concept is buffer solutions. You know very well, buffer solutions is also present in our body. In our body, for digestion of food, gastric juice will be released in stomach. It is also one kind of a buffer solution, because its pH value is constant, is not changes with changing the conditions. As well as in our body, blood is also one kind of buffer solution only, because its pH is also not changing, it is a constant. So this buffer solutions in our day usual life, it is very, very important. What is buffer solution? Buffer solution means, the definition, let's see, it is defined as the solution which resists the change in its pH. Resist the change means the pH values cannot changes. So the solutions which pH value is not changing by the addition of small amount of acids. You have to add small amount of acids, or small amount of bases, or small amount of water, means you have to do dilute, means add excess of water or some amount of base or some amount of acid, but pH value is not changing. Such kind of solutions are called as buffer solutions, means the solutions which resist to the change its pH value by the addition of small amount of acids or bases or on dilution is known as a buffer solutions. Okay ma, these buffer solutions has definite pH values. These pH values can be calculated by Henderson Scientist has calculated, has given some equations for the pH of buffer solutions. Those all later we'll discuss. Okay, ma? So this buffer solutions has definite pH value at specific temperature, and it does not changes upon keeping for a long time. Means in our body, blood is there, continuous blood will be there. It's not the blood, even you have to take either 1 day or 1 year or 5 years or long time, its pH value is not changing because of its buffer solution. By the time is going on, and pH of buffer solutions does not changes. As well as you have to do add some any other substance, acids you have to add or bases you have to add, or otherwise you have to add some water, dilute that solution also, that pH value is not changing for the long times. Okay, ma? So such kind of solutions are called as buffer solutions. Okay, let's see. Now we need to discuss about the types of buffer solutions. Types of buffer solutions. There are two types of buffer solutions are present, ma. One is simple buffer solution. The second one is mixed buffer solution. Simple buffer solution means weak acid and weak base mixture also, it's considered as a buffer solution only, but it's not that much effective, not that much use. So mainly in your textbooks, buffer solution means mixed buffer solutions only they given. So the mixed buffer solutions are mainly two types. One is acidic buffer solutions. The second one is basic buffer solutions. Acidic buffer solutions and basic buffer solutions are present. So what is the definition for acidic buffer solutions, and what is the pH value, and examples we need to remember. This much information is enough. Okay, students. What is the meaning of acidic buffer solutions? Acidic buffer solution means these are the solutions of a mixture. Acidic buffer solutions is nothing but a mixture of weak acid. You have to take weak acid and weak acid plus strong base salt. Okay, this kind of mixture is known as a acidic buffer solution. So these are the solutions of mixture of a weak acid and the salt of this weak acid with strong base. Weak acid means salt. What kind of salt, ma? Weak acid, strong base salt. That mixture of this solution is known as a acidic buffer solution. Example, acetic acid is a weak acid. Its corresponding this acetic acid reacts with strong base, NaOH. The strong base is sodium hydroxide. It is a strong base and produced salt. What is the salt will produce, dear students? CH3COO Na, sodium acetate. It is the salt of weak acid plus strong base salt. Already these examples earlier only we discussed types of salts in that case. So that mixture is known as acidic buffer solution. Like some other examples, HF and NaF, and carbonic acid and sodium bicarbonates, and hydrogen cyanide and sodium cyanide. Hydrogen cyanide is a weak acid and it is the salt of weak acid plus strong base salt. Okay, these are some important examples in your material. More examples also be there. You go through the material. These are the examples for acidic buffer solutions. These in our biologically, these buffer solutions has a lot of importance are there. Gastric juice, its pH value is constant, is not changing with the conditions. It's always, its pH value is 1.6 to 1.7, in between it will be present. It is due to acidic buffer solution. So gastric juice is an example for acidic buffer solution. Okay, students. Now the pH of acidic buffer solutions can be calculated by using Henderson equation. Henderson is a scientist name. He has calculated the pH of acidic buffer solutions. What is the equation he has given, dear students? This equation is very, very important. Based on this equation, problems they given in your textbook or in your material, you have to solve those all problems. Those all problems are very, very important for board examination as well as in a objective examination also. So the pH of acidic buffer solutions, pH of acidic buffer solutions, formula is equals to pH is equals to pKa plus log concentration of salt by acid. Log concentration of salt by acid. So this salt, this is the salt. What kind of salt, dear students? The salt is weak acid and strong base salt. So weak acid and strong base salt means weak acid produce corresponding conjugate base is strong. Conjugate base is strong. That's why that salt concentration place, sometimes conjugate base concentration also we can use. Salt is nothing but the salt, weak acid and strong base salt means the resultant salt has a basic nature. Basic nature. So the basic nature is due to presence of strong conjugate base. Strong conjugate base. That's why the salt place we can write a concentration of conjugate base also. So once again you have to remember, so that acidic buffer solutions pH is equals to pKa plus log concentration of salt by acid, or pH is equals to pKa plus log concentration of conjugate base by acid salt. Concentration of acid. Okay, next the second one is basic buffer solutions. Basic buffer solution means weak base and weak base plus strong acid salt. Same, whatever the weak base we are taking, that weak base combined with strong acid, corresponding salt. That mixture in aqueous solutions acts as basic buffer solution. It acts as a basic buffer solution. Examples, let's see. Examples: ammonium hydroxide and HCl, and magnesium hydroxide and magnesium sulfate, and ammonium hydroxide and ammonium nitrate, and zinc hydroxide and zinc sulfate. Okay, students, these are the some important examples of basic buffer solutions. Now, this basic buffer solutions pH is more than 7, and for example, the pH value of blood is maintained 7.4. More than 7 means slight basic nature. Blood has slight basic nature and it is constant, is never changes. That's why it is one example of buffer system. What type of buffer system, dear students? Blood is a basic buffer solution. Now, the pOH of basic buffer solutions can be calculated by using Henderson equation. The pOH is equals to pKb. How to calculate pKb, dear students? Kb value they gave. Then you want pKb means minus log Kb. Minus log Kb. If Ka value they gave, then pK you want means also minus log Ka we had, right? Okay. Like pOH is equals to pKb plus log concentration of salt by base. This salt is formed by the weak base and strong acid. The strong acid produce corresponding conjugate base. Dear students, weak base. So here this mixture, after that mixture, this is a weak base. Weak base produce corresponding conjugate acid is strong. That's why the salt concentration place we can write conjugate acid also. Concentration of conjugate acid. Okay, these are the important formulas. So basic buffer solutions pOH we know that. Now this basic buffer solutions pH is equals to 14 minus pOH. So this pOH place you have to substitute pOH form values. Then 14 minus pKb minus log concentration of salt by concentration of base. S means salt concentration, B means base concentration. So that is the formula for pH of basic buffer solutions, 14 minus pOH. So first any basic buffer solution pH you want to calculate means don't forget, first we have to calculate pOH. After that pH of basic buffer solution is equals to 14 minus pOH. Like base's pH you want to calculate also, base pH is equals to 14 minus pOH. So first you have to calculate pOH. pOH is equals to, for any strong bases, POH is equals to minus log OH minus ions concentration. OH minus concentration for strong bases is equals to normality of base. According that, POH will comes for strong bases only. Weak bases formulas already we are discussed. How to calculate weak base POH. POH weak base is equals to pKb plus 1 by 2 log C. That is the formula. Okay. So like basic buffer solutions, pH is equals to 14 minus pKb minus log concentration of salt by concentration of base. These are very important formulas. Okay, students. Next, basic buffer solutions over, means buffer solutions concept is over, and applications of buffer solutions important for objective purpose. Just to go through your material and read the theoretical points only, applications of buffer solutions. Then next concept is solubility concept. Based on the solubility concept, then we'll get solubility product as well as ionic product, and what is the relation between solubility product and ionic product we need to discuss. Okay, and last one concept is common ion effect. That common ion effect, how it will be affecting on solubility or solubility product we need to discuss. Okay, last concept means tomorrow we'll complete this chapter. So let's see that solubility definition. What is the solubility? Solubility means number of grams of solute dissolved in 100 grams of solvent. So with respect to solvent, the solubility definition is the amount of solute in grams dissolved in 100 grams of solvent is known as solubility. If more amount of solute is present, then the solubility will be more. So the weight of solute by weight of solvent into 100, then the solubility will come. The solubility is denoted by S. Is nothing but solubility is nothing but molarity of the solution only. Okay, molarity of a solution. Listen carefully, dear students. Next, solubility mainly depends on the nature of solute, means solute nature. Maybe the solute is ionic nature and covalent nature. It depends on nature of solute and nature of solvent, because like dissolves like, means same kind of solute and solvents are present, they can dissolve easily and forms solution, soluble solution they will form. Otherwise, the opposite means it becomes insoluble. It becomes insoluble. That's why solubility of a solutions or solubility is mainly depends on nature of solute and solvent and temperature also. Sometimes if temperature increases, solubility will be increases for endothermic solutions. For exothermic solutions, solubility increases with decreasing the temperature, and solubility of gas in liquids means gaseous solutes are present. It depends on pressure also. If pressure increases, solubility of gas in liquids increases, and temperature increases, solubility of gas in liquids decreases. So the factors affecting the solubility is mainly nature of solute, solvent, temperature, and pressure. Pressure is brackets. If it is gaseous solutes are present, then only pressure is applicable. Otherwise, liquids or solids, then not applicable. Okay, students. Now, based on the solubility concept, means the solute is some types of salts are present. Then, what kind of salts will be present? Based on the solubility, salts are three types. Based on the solubility concept, the salts are divided into three types. Three types of salts are present. One is soluble salts. The second one is sparingly soluble salts or partially soluble salts. The third one is insoluble salts. Okay, students. Soluble salts. Soluble salts means the solute is more quantity is present, more amount. Means here they gave one specified definition. If the solute is dissolved in 100 ml of, means 1 gram or more than 1 gram of solute is dissolved in 100 ml of solution, such kind of salts are known as soluble salts. These soluble salts only forms three types of solution. These soluble salts forms three types of solutions. Forms three types of solutions. Okay. Yes, ma, listen. So the soluble salts means, for example, any